In this video, we will solve a numerical that was asked in a GATE examination during the year 2020. The problem statement is 1 kg of air initially at 127 degrees Celsius expands reversibly at constant pressure until the volume is doubled. If the gas constant of air is 287 joules per kilogram Kelvin, the magnitude of work transfer is in kilojoules, round off to 2 decimal places. The first step in solving a numerical is to write the data given. The first data given is initial temperature T1, which is equal to 127 degrees Celsius. And the final volume V2 is equal to 2 times V1. So here it is given as volume is doubled. The gas constant R is equal to 287 joules per kilogram per Kelvin, which is equal to 0.287 kilojoules per kilogram Kelvin. Next, we need to write what is the quantity that is asked in the problem, that is to find work transfer. So we need to find out what is the work transfer. Of course, in the data given section, mass of air 1 kg is not written. Having understood what are the data given and the quantity to find, the next step is to look for the solution. In order to calculate the work transfer, we look for what is the nature of the process. So the process is constant pressure process. It's given here. The plot of this process in a PV diagram is like this. Initially at state 1, reaches the final state 2. Since it is a constant pressure process, horizontal line. For a constant pressure process, the work done W122 is equal to a product of pressure and the change in volume. So the change in volume is V2 minus V1. Pressure is P. If you take a look at the data, P and V1 are not given. V2 is given. Therefore, we can V2. Instead of V2, substitute 2V1, which gives PV1. Therefore, to find the answer work done during the process, the data of pressure and the volume at state 1 are required, but both are not given. But we know PV equal to mRT. This can also be written as P1 V1 equal to mRT. P1 is equal to P2 is equal to P. because of constant pressure process. Therefore, we can write P V1 is equal to M R T1, and work done is equal to PV1 is equal to 1. So the value of mass is substituted here, value of R is substituted here, value of T1 is substituted here. So instead of calculating the product of pressure and volume at state 1, we are calculating the product of mass, gas constant and temperature at 1. These three data are given and their product is equal to the work done. The work done finally is 114.8 kilojoules.